Okay, so this is my code for assignment 4. So read maximum just opens the max.txt file, which is found right next to the assigned4.c file, which is the C file that has all of the code. So max.txt just has the different customers here. This is customer 0, 1, 2, 3, and 4. And basically, it just has the different values for how much each resource can take up for each customer. So for customer 1, this is A, B, C, and D. So the file, or the read maximum function, just opens the file, and then it ensures that the file max.txt does exist, and then also it makes sure that the formatting is correct. So we have calculate need here, which just figures out how much the customer still needs in order to finish. So that's just found with a simple function. Need is equal to maximum minus allocation. The Baker safety algorithm, this just makes a copy of all of the available resources. It sets all of the processes to being not finished. And then it goes through all of the processes and checks if they are able to finish safely. And then it simulates the processes finishing. And then there's just a break here to, in the event that there's nothing to do, then it has a way of breaking out safely. And then it just checks to see that all of the processes are finished. We have the request function. And so request is just used to find, or to, it requests resources from the customer ID here. So when I run it later on, I'll show how both request and release work in terms of getting the resources from one place to another. And then we have print array and print state, which just prints the resources. Print state does the available resources, the maximum, the allocation, and the need for each customer. And then we have the main function, which just has all of the statements for the beginning. So if we exit this and we compile the code, assign 4, assign 4, so it'll overwrite the file that I have, and then we run it. So unlike with the other assignments, this one has some parameters that we have to fill out. So let's say I'm going to go with some large numbers, 8, 7, 7, 8. So it says, welcome to Baker's algorithm simulation, initializing system with resources. And then it just tells us the amount that we have available, same amount that we just gave it. It reads the max.txt file. It asks us for the command. So we're going to do a request, a request command. And we're going to say customer 0. First parameter is the customer's ID, and then the resources. So I'm going to give 0 for all of the resources except for 1. I'm just going to do the first resource. Actually, before I do this, I should show right here the resources here. So this way we'll be able to see a before and after. So request from the 0 ID, 3, and then 0, 0, 0. That's 3, 4, 5 numbers. It says that the request has been granted. So now if I check again, we can see that customer 0 does have 3, 0, 0, 0, and the rest of the customers don't have anything. We can actually see that the available has gone down. It is now at 5, 7, 7, 8, which is just 3 less in the first resource, and then the rest are the same 7, 7, 8. So that's where that math function comes in, where it just subtracts it from the available. So if I were to try that again, let's request 4 now. Zero customer 4000. That's 3, 4, 5 numbers. It says request has been denied. So if we release the 3 from right here that we took earlier, we release from the 0th customer, we release 3000, and then we now request that back. The original command, the 04000 that was denied before, now it's been granted because that resource has been released and now allowed us to make that request. And so the banker's algorithm just ensures that the resources can be released without causing a deadlock, where the processes are happening at the same time, and the issue is that if multiple processes are requesting information, it could cause a deadlock where it doesn't know which one to satisfy, and then they can get stuck. They can get stuck waiting on other resources that aren't available to be released. So for resources that helped me with this assignment, I used this website, which actually details the banker's algorithm in C++, but I was still able to use that to implement it in C easier. And then I also used this. This was actually the first resource that I used just on understanding the banker's algorithm.